Hi everyone. So I'm just going to go over elimination. So right over here we have this system in front of us. I already named it and I've identified the variables I want to eliminate. So those will be the t's right over here, right? Because you have a positive 4 and then you have a negative 4t. So I know that if I combine the first equation by the third equation, I should be able to eliminate the variables. So let's go ahead and do that. Let's combine the first and the third one. And here is the third one. Right? And then I can go ahead and add. So negative 4 plus negative 16. This one over here would give us a negative 20. A positive 4t plus a negative 4t will eliminate. And then you have a negative 4s plus a negative 3s. This should give you a 7s, negative 7s. And then you have a 4r plus a negative 3r. This should just give you r. So at this point, I can't say anything about these variables because there's two of them. None of them is by themselves. So I'm going to keep this equation for later. Next, okay, I want to go ahead and combine 1 and 2 together. But the thing is, the second equation has a negative 2t. Now, if we wanted to get rid of the t's, I need to change this negative 2t into a negative 4t. So before I do anything, I actually want to go ahead and take that second equation and I want to multiply it by 2. Just so I can get that negative 4t and so I can eliminate the t's. So I'm just going to rewrite equation number 2 and I'm going to multiply this across. So you have 8r plus 2s minus 4t is equal to 10. Right, so I just changed that second equation and I could go ahead and add it with my first equation. So you have the first equation plus the second equation. Let me write the first equation down here. 4r minus 4s plus 4t is equal to a negative 4. All right, so you want to go ahead and add these two. So 10 plus negative 4, this is a 6. These cancel out. 2s plus a negative 4s, this is a negative 2s. And 8r plus 4r, this is just a 12r. Okay, so again, I can't really say anything about this equation since none of the variables are by itself. So I'm just going to go ahead and leave them. Now, as you're using elimination, you just want to continue using this until you are left with just one variable. So let me just go ahead and write 4 and 5 over each other. So this is equation number 4. I'm just rewriting them. And this is equation number 5. Right, so these are my two equations right over here. Now I can multiply one of them so I can get rid of a variable. And it'll be easier for me to multiply this because r is by itself. So for me to eliminate the r's, I need to make the r over here into a negative 12. And the way I can do that is if I multiplied everything by a negative 12. So let's go ahead and do just that. So I'm multiplying all of this equation by negative 12. Let me write the answer here. So negative 12 times r is just negative 12r. negative 12 times negative 7 is just a positive 84s. And negative 12 times a negative 20 is a 240. Okay, and you just want to keep going. You're going to add these two, just combine them. 6 plus 240 is just 246. Negative 2 plus 84 is 82s. And these two cancel out. So we have the s by itself. We can just go ahead and divide both sides by 82. And 246 divided by 82 will just give us 3. So s is equal to 3. Now I have one of the variables, but the thing is I need to find the other variables, right? So I have these original 3 equations over here, and then I have 4 and 5, right? 4 is r minus 7s is equal to negative 20, and 5 is 12r minus 2s is equal to 6. Now the thing is, if you noticed, it was much easier for us, like we were able to solve for s as soon as we got rid of that r, right? As soon as that r was covered and s was by itself, we were able to get that value of s. So now we have to choose the best equation where you have s and one other variable. And if we look at the original 3 variables, we have s covered, but we have r and t. If we look at 4 and 5, s is covered, but we have just r left over. So we're good over here. So let's actually use equation number 4. So let me get the blue ink right over here. So I'm just going to rewrite equation number 4. So 4 was r minus 7s is equal to a negative 20. R I'm going to leave alone, but 7 I'm going to change it into a 3. Okay. And then over here you have r minus 21 is equal to negative 20. You want to go ahead and add 21 to both sides. And r is going to equal just, negative 20 plus 21 is just 1. So now we have that second variable. So we have s and r now. The only variable left over to solve is that t, right? So since we have the value of r and s, we have 2 variables. Now you can use the original 3 equations to find t. So let's use that second one. So let me just use this color. So this is the second equation. And we have 4r plus s minus 2t is equal to 5. Okay? So we have r, we have s, and we can go ahead and exchange everything. So r is just 1, s is just 3, minus 2t is equal to 5. 4 times 1 is 4, plus 3 is minus 2t is equal to 5. 4 plus 3 is 7 minus 2t is equal to 5. Subtract 7 on both sides. And you would get negative 2t is equal to negative 2. And you just want to go ahead and divide both sides by negative 2 to get that t by itself. So negative 2 divided by negative 2, t is going to just equal 1. So these are my 3 answers. R, S. Okay, so R is 1, S is 3, T is 1. So if I put them all together in alphabetical order, R, S, T. So this is 1, S. Oh wait, 1, 3, and 1. That's the system this is the answer to this system. Okay. Now you have an example right over here. So what I'm going to do is controls. Oh wait, control. Oh, okay. All right. So here's your problem. I want you to take this time in this part of the video just to pause and try to solve this one on your own using that same exact method we saw right over here. Right? So we're now working on this problem. You can work on it yourselves, and I'm going to reveal the answer below. Okay, so this is the part where you have the video where you want to pause, try this out. Okay, and then now I shall reveal the answer. This is weird. Okay, so right over here, again, I was able to identify that you can get rid of the y's, right? You have a positive 5y, and then you have a bunch of negative 5y's, right? So over here, we just combined 1 and 3 together, and 2 and 3. I didn't have to multiply this time. And when you combine them to put them together, when you combine those guys, you have the equation 4 and equation 3. Equation 5. And now you want to keep going. You just want to keep combining these equations until you have nothing left. So that negative 2z and the positive 2z cancel out, and you have x is equal to a negative 1. Now that you have x is equal to a negative 1, right, you just have that one value. I decided to plug it into equation number 4. So you see how I just rewrote equation number 4, x minus 2z is equal to 7. I changed x for a negative 1, used inverse operations to solve for z, and I got z is equal to negative 4. Next up, I see that I have the x and z values. I took those two values and I put it into my original 3 equations because now I have 2, I'm just missing one more. I chose the first equation and I got y is equal to a negative 4. So my full answer is negative 1, negative 4, and negative 4, right? So this should be like a similar idea of how you're trying to solve these types of problems.